बच दूसरा
Hello, good morning, class.
ठीक है ठीक है
So we are starting. We have till now we have finished unit number one, three,
ठीक है
and
मैं
four,
डिस्कस कर लेती हूँ
right? So today we are going to start with unit number two. Okay, so class, let's get back to the class. So in the previous classes, we have covered unit number one, wherein we studied about types of data warehouses, data marts. And then we also covered unit number three, wherein we studied predictive analytics and its use in marketing, healthcare operations, and finance. We also have covered unit number four, wherein we discussed about technology analytics, solutions, and management. In today's class, we are going to start with unit number two, which is about data analytics lifecycle, different data exploration and data visualization techniques, linear regression, logistic regression, then different classification techniques like decision tree, clustering, association rules, and market basket analysis. So let us first start with data analytics life cycle. So when we talk about predictive analytics, it depends only completely on the data science. Data science is a field of statistics, right? It is a field which deals with the statistics. We first identify what are the statisticals of the data available. Next, we also visualize the data. Data visualization is depicting the data, whatever the data has been collected, depicting it in the form of a graph. It could be a pie chart, it could be a bar chart, or it could be a histogram,
Ma'am,
it
could you
could be
please
line
share the
chart, or
screen?
it could be scatter plot.
Ma'am, could you please share the
Once,
PPT?
hello?
Could you please share the screen of the PPT?
Okay, screen is not shared. Just a second. Hope the screen is visible now.
Yes, ma'am.
Okay. So here we are talking about the data statistics visualization, right? Then once the data has been collected, we have got understood its basic and statistical technique statistics. What is the mean, median, and average? We perform certain data mining techniques or pattern recognition techniques, or we may apply machine learning algorithm, right? So this is about data science. Now, when data science, it starts first with data collection. Always remember, data is the most important part, and the most important part is data collection. The data is collected from different sources. It is user generated. If I am talking about the forecasting weather, the data is collected from the sensor data. If I am searching or talking about the reviews of a product, or certain post on a social media platform, we collect that data from that particular social media platform. Again, when if I have to analyze certain marketing data, certain sales data, or the spend analysis of a particular person, individual, or an organization, we call it as transactional data. So this sort of data is being collected, right? Next. Next, once next, when whatever data has been collected, we don't utilize it as it is. We first pre-process it. Pre-processing means we are formatting the data, we are deleting the duplicates, we are eliminating any discrepancy, we are removing blank spaces, or we are trying to maintain the accuracy, right? If there are any outliers, we may also remove it. So pre-processing of the data is to ensure quality and maintain accuracy. Now once the data has been collected, we identify the important as well as the relevant features. Now the relevant features, at times, if I am collecting data, for example, about about the result, right? Result of a class. And at that time, I have collected the student's contact number, student's email ID, student's roll number, and the marks of different subject. If I have to find out the average, what is the relevant feature? For finding out the average marks, I will perform calculations only on the marks column, right? Only on the columns which are the subjects field. But I am not going to do any calculation on date of birth, on mobile number, or email ID, right? So while performing result analysis, mobile number, contact emails, contact details, email name, they are irrelevant features. We can skip it. So this is how we are selecting or identifying the important as well as the relevant features. Next is once we have analyzed and identified the important features, the relevant features or the relevant columns, we start discovering the hidden patterns. We study about their distributions, and this could be done using data visualization, some graphical tools, uh, showing the data in using these scatter plots or line graphs. Then we apply statistical methods. Statistical methods are basically to discover the trends. Now, after this, we may perform natural language processing if it is about the text, it is about reviews, it is about tweets and posts, or if it is about the human language. We may apply machine learning or deep learning models so as to study so as to classify or cluster, right? Or to predict any future outcome. Now, processing this, since we are dealing with data, with huge amount of data, we have to choose the algorithms or techniques in such a way that reduce the complexity. We have to reduce the complexity and increase the performance. These are the two basic things, two important things while choosing an algorithm. Above all, we have to take care about the ethical as well as the legal aspects of data collection and storage and usage. For example, if I am collecting a data, I have to be careful about the social security number. I have to be careful about the Aadhaar number. If I am collecting data, we have to be careful about the credit card numbers. Earlier, credit card numbers were stored in plain text. Now, the policies have been changed and they are like store the credit card numbers or the password in encrypted form, right? Certain things are not being collected even if we are using it, but it is not being collected. For example, if I have not given the access of the location, right? अगर मैंने location का access नहीं दिया है, so the location will not be stored. But yes, though certain financial uh, applications, they are collecting the locations to track the frauds, right? They are trying to track the frauds also. So they collect the location from where the transaction is being done, right? Similarly, whenever we are performing experiments, we have to first plan and execute it in a controlled manner. And then we identify the patterns, relationships using the different data mining, machine learning techniques. It could be clustering, association rule, detecting anomalies, identifying clusters, classifying, and any model. Right? So, this is all about data science. Okay. So next part is the difference between a data scientist and analyst. See, if I talk about data analyst is only cleaning and transforming and generating the data, right? The data analyst is in getting the inferences from the data, whereas a data scientist is dealing with different operations. His role is not only about cleaning and transforming, his role is about to get certain insights or hidden patterns or relationships between the data. uh, Data analyst deals with only the structured data, right? The structured data could be result, it could be related data, or some financial transactions, or some healthcare data. Whereas data scientist, he or she deals with the structured as well as unstructured data. Unstructured data includes media. Media is images, audio, videos, tweets, reviews, messages, emails, right? Any form of textual data or any form of mixture of text, audio, and video. Next is skills. A data scientist has knowledge of advanced mathematics, statistics, and machine learning algorithms, whereas a data analyst has limited skills. The data analyst has limited problem solving skills and basic knowledge of the statistics. As a data scientist should be proficient in data scientists, they are proficient in SAS, Python, R, and different programming languages, whereas the data scientist has to be aware of the basic statistical tools like R, Tableau, Excel, or SQL. Now, when I talk about data analytics life cycle, the first one is defining the problem. See, I cannot start collecting data randomly. I cannot start collecting data if I am not aware of what the problem is and what the solution we want. So, the first and the foremost thing is to define the problem first. Once the problem is defined, we then collect the data, right? We collect the data first. After the data collection, we transform it, we clean it, we perform data cleaning operations, data formatting, data cleaning operations, and then we perform the data exploration. Data exploration, it includes applying statistical techniques to find the mean, median, average, mode, standard deviation, to study its distribution, to find out, to represent it in the visual form, right? After this, after the first four steps, we go for the data modeling. We go for data modeling techniques. Now, this data modeling techniques, here we apply advanced algorithms, and then we evaluate their evaluation or their performance. It might happen that first algorithm is giving me X prediction and second algorithm is giving me Y prediction. So which one is better? Or which one is giving me the actual prediction? That we evaluate. Once we have compared and evaluated the performance of different algorithms, we decide, right? This is the decision making. And once the decision making is done, we perform the continuous monitoring. So this is basically the data analytics life cycle. So next, we have already covered the data collection and data transformation in the unit number one. Here we'll start with the data exploration techniques. Now, data exploration is basically is consisting of two parts. One is summary statistics, wherein we find out mean, median, mode. standard deviation, variance, percentile, quartiles, and the second is data visualization, wherein we show the data in the form of scattered plots, in the form of histogram, box and plots, bar charts, or pie charts. We show the data in the form of uh, in the pictorial form. So data exploratory analysis, we have first correlation analysis. We do have correlation analysis wherein we identify relation between two variables using Pearson correlation coefficient, Spearman rank coefficient. Then we perform categorical data analysis using frequency tables and cross tabulations. For multivariate data analysis, we show the data in the form of a scattered plot or coordinate plots, right? At times we perform principal component analysis, but we'll study it later. Another techniques, few more techniques that are available in data exploratory analysis is the outlier detection. Wherein we calculate Z scores, right? Then we have interquartile range, wherein we find out the gaps between the first and the third quartiles. Then we have normality test, where we see whether the data that has been collected is as per the normal distribution rule or not. Whether the graph is whether the data is not following the normal distribution or not. ऐसा तो नहीं है कि हमने सारा डेटा 90% above students का ही collect कर लिया and there is no student who has scored less than 90% marks. It means the data is not normally distributed. It is showing me only the reviews of 90% above students who have scored above 90%, right? We say that it is a skewed data, the data which is showing me the reviews or feedback of only a set of students, right? So we perform distribution fitting also, wherein we check what that the data that has been collected is covering a wide range of uh, variety, right? If it is a result analysis, it is covering a wide range of student. If it is the feedback, it is covering a wide range of the customers, right? Next is geospatial analysis. When the data is collected about the location, we draw heat maps and chloropeth maps, right? Which use different colors and patterns to represent data in different geographical areas. Actually, these heat map and maps, they use color gradients, right? They use different color gradients to show the geographical map. Next is time series analysis. The next algorithms are time series analysis, wherein we display the data over a particular time to identify trends, seasonality, and patterns. And the fifth technique is the dimensionality reduction, wherein we try to reduce the high dimensional data. High dimensional data, it means like I can say if I have 1,000 columns in a data, 1,000 columns, and they all are relevant, they all are important. So what we do, we combine those 1,000 columns in such a manner so as to reduce them into 10 columns. For example, now with these 10 columns are manageable, right? Best example is I'll take an example of result. I for each subject, you have tutorial, you have practical, and you have a theory exam. Okay. And then total marks. So if I am having five subjects, each subject is having four columns, so total 20 columns. How I can reduce it? Instead of analyzing theory, tutorial, internal assessment, continuous assessment, and practical individually, I am analyzing only the total marks. So this total is a combination of the other four columns or three columns. So this total is the uh, this operation. What is the operation I did? The operation is summation, and I have created a column. I have created a feature which is combining four more columns, and now I am analyzing it. So this is a sort of dimensionality reduction wherein we reduce the number of columns, number of features, and combine them in such a manner that they represent a group of it, right? Next is the foundation of predictive analytics. Yes. Okay. So next is, what are the different foundations of predictive analytics? Now, predictive analytics is basically integrating the data science. It is integrating the machine learning algorithms, the natural language processing algorithms, different modeling techniques, and to identify what it is trying to identify, the essential insights, right? Which is unearthing the essential insights to find out the hidden patterns. It is basically based on the historical data, right? And we are using a certain mathematical and statistical modeling. And these findings helps us to predict the trends, to optimize operations, to improve decision making, and to enhance customer experience, and above all, to minimize the risk associated, if any. For the learning about predictive analytics, we have certain techniques. The first one is linear regression and logistic regression, right? Next, we have decision trees and we will perform the model comparison. So let us first start with linear regression. Now, what is a linear regression? Linear regression is basically we try to predict the value based on the another value. And the one which I want to predict is called as dependent, and the one which is giving me the base or the historical data is the independent variable. So, what if I talk about linear regression? Here, what we are doing, we are plotting the data points, we are plotting the independent points on a graph. The graph could be a XY plane here, and then we try to draw a line, right? This red line, this we try to draw a line. This line is called as line of regression. When on this basis, they, we can predict the next outcome. We can predict the Y outcome. So here we have linear regression, we have multiple linear regression, we have then logistic regression, ordinal as well as multinomial. In this course, we will be studying linear regression and the logistic regression. Now, what is this linear regression is about? Here, when I talk about anything linear, we talk about a linear equation. We have a line. Here, the linear regression analysis, we have a line wherein it is y equals to b beta naught b1 plus x plus epsilon. We can say that this xi is the independent variable, right? This is the independent variable which is not depending on anyone. And y is what I want to predict, what the value which I want to predict. This beta 1 and beta naught, they are the population coefficient. We just give it a name as a coefficient, right? Wherein beta 1 tries to show me the slope, how tilted is the line, and beta naught is the intercept of y. In simple terms, I can say it is of this form: y is equals to a plus bx. This b is the slope, right? This is the slope, and a is the intercept, or it is the uh, difference from where the line is being started from the y point. Another component that is added is the epsilon. Epsilon is basically the random error value. If we say that this error might be there, you can see that if I draw the data points, these blue color are the data points, and then I draw a line, you will see that this x with the corresponding value of x, the y value, if I predict the y, this is the predicted y, right? This red color is the predicted y. But actually, we have observed blue point. The difference between the predicted as well as the observed is called as an error. There is some error. So we take the error point in the regression analysis also. So epsilon is the random error, any error that can exist between the predicted and the observed value. Now, linear regression could be of two types, three types. First is a positive, second is negative. If one positive is if one value, if one variable is increasing, the other variable is also increasing. The negative is if one variable is increasing, the other variable is decreasing. And there could be no relation between the two variables. Let us perform a question about least square regression line. What is a regression line? How do we draw it? And what is the least regression? Now, in the previous, I told that there is some difference between the predictive value and the observed value. This error is epsilon. You will see that in this point, the predicted and the observed value is very close. Wherein for this particular point, the point which is being marked as green, the observed value is large. The difference between the observed value similarly, the points which are being marked as purple, the predicted as well as the observed value is very similar, right? There is a very less difference. Same here, this yellow. Now, multiple lines I can draw another line also. Let me draw. If I want to reduce this, right, I can line in for this line. What is happening? The maximum points are close to it, right? Only this point, the point A. Only the point A is very different from the others, but rest are all very close to the predicted values, right? So, how do we find out which line is better? For these different points, which line is better? So, what we do, we find out the errors. And with these errors, we try to minimize all the errors, right? We try to minimize all the errors. This is called as a least square regression line. Okay, so for this least square elevation analysis, what we do, we first take the equation of line, right, which is y equals to ax plus bx. This y is y cap. We call it as y cap or y dash, which is predicted value. Next, what we do, we find out the value of a, right? And here with this a, what we do, we calculate the standard deviation. Standard deviation, which is the difference between the x value and its mean. X bar is mean. And another is y and y bar, right? And when we solve this, we get the equation that summation xy and minus summation of x and summation of y. See, this summation of x is nothing but the x bar and y bar, right? This x is x bar and y bar. So, what we get, we have received the predicted value as y equals to a plus bx. Now, let us consider a simple question. So, let us consider a simple question. Consider the example where the mass y, right? I have a relation between a chemical and its time, right? The chemical is taking a particular time for a particular chemical reaction. So what we are doing, I have to calculate the values of A, right? So what we have done, we have taken the y bar. The value of A is given by the equation y bar minus b x bar, and the value of b is given as SXY, standard deviation of x and y, divided by standard deviation of xx. So how we have done it? So we have the x values and y values. First, we'll find out the x mean, the x bar or the average. I have taken all the values of x, which is 5, 7, 12, 16, and 20, and divided by 5. I got the x bar as 12. हमने सबसे पहले x और the dependent variable, sorry, independent variable का average find out किया, right? Next, we find out the average or the mean of the dependent variable. ठीक है? We have received the y bar as this. Now see, these x and y are the observed values. These are the experimental values. There is nothing prediction here. This is what has actually happened. Then we will find out the value of b. The value of b is the basically the constant or the slope, which is obtained by Sxy upon Sxx. Here, what I am doing, I am subtracting each value from x bar. For example, 5 minus 12. What I am doing, 5 minus 12 is minus 7, and then multiplying it by 40 minus 158, right? Similar calculations have been done. And then we have received the value of B, which is 12.208. This 3 dp is 3 decimal points. I have taken the values up to 3 decimal points. Now I have calculated the value of A, right? This is a simple calculation. I have taken the observed value, experimental value, or the data collected value, use the simple statistical analysis, wherein we have calculated the mean as well as standard deviation and find out the value of some constants. calculation each value. The mean was 512, so which value received 7. Next, we have subtracted each value of y from the average, wherein we get minus 118, and then we have multiplied, right? You can see that we have multiplied it, the x and a y, and we have also done the square, and these are the simple calculations that have been performed. You can note this calculation down, or you can take a snapshot of it, right? I'm giving you 5 minutes so that you can take the snapshot of it. the question that we have done to find out the least square methods using linear regression. Next, let us see how the students' reaction skills have improved over a year. So I have two data sets. I have two data. First is the first test for different students. There are 8 students. They have given first test and second test. So can we predict what would be the marks, or can we predict on the basis of first test what the student will score you in the second test, right? So what we have done here, again, we have considered first as the independent and second test as the dependent one, right? So we have find out the average. X variable का हमने एक average निकाला. This is the total, and then we find out the average here, which comes out to be 64.375. Next is Y, right? Summation of Y and its average comes out to be 28. Then we find out the summation of x square. हम एक एक वैल्यू का स्क्वायर करेंगे और उसका टोटल फाइंड आउट करेंगे. And then we will calculate the value of B as well as A. Here what we are doing, we are finding out a regression line. We are finding out regression line from the observed values or from the observed data. So the equation of, also the predicted value of y comes out from this particular equation, wherein we first find out the b value of b from keeping the formula, right? We got the value as 0.59 and the value of a as minus 10.016. So this is the equation for the predicted value. Next is the logistic regression, and this we will cover in the next class, right? So you can note down this particular question and its solution, or you can take a snapshot of it. And the next part of the unit number 2, that is logistic regression, will cover up in the next class.